Now let's look at this figure 17-30, and it deals with grounding. Grounding systems over 1,000 volts in accordance with 250.20c, 250.180, and 250.184b. Now notice in the boxed in information at the very top of the illustration, we list grounding sections for over 1,000 volts and 1,000 volts or less. Equipment grounds in accordance with 250.118 can be pulled with a metal raceway or a non-metallic raceway. The conductors in 300.3b should be pulled and arranged, as we just previously seen in a previous illustration, 17-29, to prevent electromagnetic field that would heat up the metal conduit. So we had either 3 ungrounded conductors, 2 ungrounded conductors, an ungrounded conductor with a neutral with current coming and going to cancel out the magnetic field, so it has no effect on the metal. And then, of course, single conductors in 300.5i is further discussed, with an exception over there under 300.5i that says, well, now, if it's all non-metallic, and for example, if you look at this illustration, say that we had a magnetic top. It's not metal, it's non-magnetic, and we run the non-metallic conduit over to this equipment that you see to the right, and it has a non-metallic entry point. Then we could put all the L1s in one conduit, all the L2s in the second conduit, all L3 in the third conduit, and we wouldn't have to pull L1, L2, and L3 in conduit 1, 2, and 3 that you see there. But we'd have to use the exception over there to 300.5 to be able to do that, see. And a lot of folks don't realize that you can isolate and do that, see. And what we're saying, you're just isolating metal so that you don't heat it up and create a problem. Now, grounding requirements can be found in the last part of 250. Basically speaking, any article that deals with high voltage, over 1,000 volts, will be the last part of that article in most every case. And then for shield grounding, see that note too on page 17-17 in Stallcup's electrical design book. We can, and you know, designing electrical systems is the actual name of the book, but I still call it Stallcup's electrical design book because you're designing electrical systems of some sort when you use volume 1 and 2. So that's what this illustration 17-30 is illustrating, is that grounding is required. And in 250.118, we very definitely can use a metal conduit and pull an equipment ground and have redundant grounding. If for some reason a restriction occurred in the metal raceway system due to a coupling or a connector or connection, whatever, the equipment ground will pull what the conduit would not pull. But basically speaking, the conduit from the equipment to the right will pull about 90% of a fault back over to the main equipment to the left, the service equipment. The equipment ground only pulls 10% when everything's installed properly. But if the metal conduit should develop a restriction of some sort, and we're just saying this, and pulled only 70% of a ground fault, then the equipment ground would pull 30%, making it a complete system. Now we see that in 250.118, 310.6, and 310.10, and actually I believe it's 310.10 that would address the identification or color coding of equipment grounds. And 310.6, I think, addresses where you can use the insulation in a wet, dry, or damp location, or exposed to the sun, what you would have to do and that kind of thing. So that's what this figure that we're looking at here, 17-30 is illustrating to the user of the NEC.